Hello, everyone. This is another screencast for research methods. And what we're going to be talking about today, what I'm going to be talking about, is quasi-experimental design, design typically known as post-test only, two-group post-test only, and how to gather information from probably the little information you have in that design to help address some problems with internal validity, which is always a problem with the quasi-experimental design. So first I'm going to give you the setup to the data set. And it's a different data set than the one that we've seen before, so I will be loading it to the classroom. So I've got a little PowerPoint acquainting you with it. So this, as I said, is a two-group post-test only quasi-experimental design. In your textbook, it's called a static group design, which I assume means that one of the group, the non-experimental group, is just some naturally occurring group that has no manipulation or control by the researcher. Static group, that's in the textbook on page 416. Static group is not a term that I have heard used or that I've worried about its use. I may have run into it somewhere, but it's what the textbook uses. Nomenclature varies sometimes in social sciences, and it's annoying, but not something to worry about very much. So we're going to be looking at this data set, which is in Classroom, and it is called Preserve Teach Math Quasi. And what the situation is that you have a researcher who has been given access to administer a short intervention over 2 class periods to several sections of a math methods class that's geared for pre-service teachers in childhood education in a school of education. These are undergraduates and graduate students. However, the researcher can do this short intervention in some sections of the course, but some instructors say, no, we will not allow you to do this in our class. We're not willing to give up the class time. So not all the candidates receive it. But all the instructors are willing to administer a survey at the end of the semester. So what you have is you have this treatment group and you have a non-randomly assigned group that you can administer a post-test to, but that's all you can do with them. And you have no control over how some people got into the treatment group or not. They're just the people who were there, you didn't assign them. So it's a quasi-experimental design, no randomization. So we have the researcher and their research questions. The design is perhaps not what they would have wanted to be, but it's the design that they had to accept given the circumstances that are associated with field research. They're interested in pre-service teacher education, and they go where it is, and they have to make certain accommodations for the access to the teachers. So their research questions, which are design, the design depends on the research questions, but it doesn't really know about randomization. Research questions does hands-on instruction in inquiry lessons about how to teach real-world math increase the interest and the skills of future elementary school teachers? So the intervention, which is a short intervention over 2 class periods, is some kind of hands-on instruction in inquiry lessons about how to teach real-world math. And the post-tests are going to be an interest in math survey and a math skills survey. So you see the hypotheses written in kind of statistical language, and the hypotheses or the null hypothesis is that there is no difference between the treatment condition mu1 and the non-treatment condition mu2 on interest. And the research hypothesis is that there is a difference between the two on interest, and the same on skills. So the question is there a between groups difference on either of the constructs measured in the post-test? Prior to collecting the sample, the researcher probably wants to know how many people should they try to get in, because you want to avoid what's called a type 2 error. You want to avoid the probability or the possibility that there may really be some kind of significant difference between the treatment and the non-treatment group, but you don't have enough people or statistical power to detect it. And we want to find that out. So what I'm going to do, you've heard about G-Power. I think Bhumi told me that John had covered G-Power or introduced you to G-Power in his class. And G-Power is great. I use G-Power all the time, but there's certain things that G-Power either does that are confusing or anyway, I want to show you an alternative that I've found works pretty well. I've never found any big problems with this site, and it has a lot of stuff on it. So that's why I'm going to show it to you. It's Daniel Soper's site, and I believe I'm going to have to make a new share with this once we get there. Yeah. Okay. So Daniel Soper site has free statistics calculators for all kinds of things. Now, I never go into any of these things, so I don't know what these are like. The only thing I ever go into is sometimes I go into effect sizes, because you may have seen that in SPSS you have to hand calculate Cohen's d. It isn't given to you. It's really easy to hand calculate, but sometimes it's annoying. So there are a lot of online calculators that will do effect size for you. And it does sample size and power analysis. The power, we won't do they're the same essentially. One of them is for before you gather a sample, that sample size, and one of them is category for finding out after you've calculated a sample how much power you had. But the researcher is being very good about this, and it's trying to find out how many people they need before they start. Presumably, they could carry their study over into 2 semesters if in one semester they didn't have enough people. So which one do we want? Well, we only have 2 groups, so we're going to be doing a t-test. And a priori, we want to find out before we collect the sample how large a sample size we want. So here we go. And you have to give it this information. It knows that you're doing a t-test, which means if you're doing a t-test, you have 2 groups. You may be doing a one-tailed or a two-tailed test. In this case, if you remember the hypotheses, mu0 equals mu1 or mu0 does not equal mu1. There was no directionality. So this is a two-tailed test. And the first question is, how large an effect size are you anticipating or would be of interest to you? And this is the hardest question to answer. Usually you get this from prior literature. Um, Sometimes you just get it from what you know about social science research. This, you may remember, given the rough rules of thumb that Cohen set up, which nobody likes, but everybody uses, a Cohen's d of 0.5 is considered moderate. What Cohen's d of 0.5 means is that one group is half a standard deviation different from the other. And half a standard deviation is pretty much, like on the SAT test, half a standard deviation is 50 points. So I'm pretty impressed with half a standard deviation. If I can ever get half a standard deviation difference in a study, I'm like, wow, that has a bigger effect than I ever would have thought. So we're going to be satisfied with 0.5. Then it asks your desired statistical power level. So your power is the probability that you will detect an effect if an effect is there. Or another way of saying it is that you will not make a type 2 error. And so this means, well, you have an 80% chance of avoiding a type 2 error. That means that you have a 20% chance of making one. You have a 20% chance that there will be in the real world, which doesn't exist, a 20% probability that there is a difference between the two groups, but you just didn't have enough people, probably people. You were either trying to detect too big a difference or you didn't have enough people to find it. So 0.8, a 20% chance is a lot. A 10% chance is cutting yourself like, wow, this really has to be, I really have to be sure that I'm capturing it. So I'm going to change that to 0.85 just to make it seem like I'm a little bit more ambitious, but I don't want to be cutting myself. I want to give myself a little bit more power, but I'm afraid I can't get a big enough sample size. We can mess around with this. You can see the more power you want, the bigger a sample size you need. And the probability level is your alpha, and you're going to be using 0.05 because that's traditional, unless you go for 0.01, which again will require larger sample. So if you calculate that, hope that I'm sharing new screen. I hope I am. I'll have to check that. You will see that for a two-tail test, you need at least 146 people, which is 73 people per group in the independent samples t-test. So that's kind of his target number. He probably wants to get some more than that because he wants to be sure that he's got as much power, but he wants to get at least to that or close. So if he's only getting 50 people in one semester, probably going to want to do it for 2 semesters. So I'm going to go back to the slideshow, which is almost over, and introduce the rest of what I'm going to do in this screen share. And I'm going to pause briefly here to find out how long we've been going. Okay, hello again. I believe I've restarted recording, but I can't maximize my screen. So I am going to stop this meeting and start a new meeting for the second half of the screencast. And I think that that will be a good idea anyway, because I tend to go on too long. So I will see you for part 2 whenever you want to watch part 2.